Namaste and welcome to CADEC learning series. In this video, we'll see some background and nomenclature of CADEC. So this is kind of a precursor to use CADEC. So this is an elementary or initial information about CADEC. So first of all, in short, CADEC is a DIY design automation tool. So DIY stands for do it yourself, and it's a design automation tool which you can do yourself for complex industrial products. Now, where CADEC is relevant, basically for what kind of use CADEC should be considered, is where you have a very complex geometry. Then each order needs design customization. You have control over layout. This relates to creating a generalized master model of your product family. Then there should be a willpower to standardize the design process. So this willpower is required in the company management as well as in the champion designers. Then companies who develop their own technology over years and they want to generalize and modularize their design process. For them, CADEC is relevant. We'll also see where CADEC is not suitable. CADEC is meant for uh, uh, design automation, and it is not meant for R&D and D and new product development, and it is not for contract manufacturing and project execution kind of companies, because contract manufacturing and project execution companies, they don't have ownership of the variations, and they don't have ownership, they don't have control over the variations also. So they are not in a position to and not motivated to develop a configurator. Now let us see uh, what is the objective of CADEC, or why CADEC should be used. So CADEC is not for R&D and D and new product development. So what is CADEC for? So CADEC is for application engineering. Application engineering is a process of making your custom product suitable for every inquiry based on the size, capacity, layout, functionality, efficiency, safety, integration, accessories, etc. Uh, and it's a knowledge capture and automation tool. That means that the knowledge that your company has generated over lots of years, and because of your experience, you can create some empirical relationship or rules, and you can use those rules and knowledge for automating the everyday design creation process. Now, the kind of industries which find CADEC useful, or where who are using CADEC as of now, are various process equipments, then material handling, fabricated and sheet metal products, hydraulic systems, robotic and fixtures, testing and packaging machines, special machines and customized tools, then instrumentation and control, etc. So we'll see what are the benefits of CADEC. Of By using CADEC, companies are benefited first in terms of custom designs in minutes. It reduces the customized design times drastically. Second is it frees the designers for doing more R&D and innovation, and avoids their routine or mundane uh, repetitive work. Third is it definitely grows your business and increases your operational efficiency. Now, after seeing these basic background about CADEC, let us see uh, some nomenclature about CADEC, because in the various videos you will see that there are some names or some jargons in CADEC are mentioned, and it is better that any new user is aware of the nomenclature. So, product family is a large variety of product designs of the same type or class. The product class is a generalized class for a product family. Then mm, uh, design instance is a is derived object from the product class, and class is an abstract thing, and object or design instance is a specific instance of the class. So when you generate a class, when you define a class, and when you want each individual custom design, you create various design instances from the class. Configurator is a tool to define and test the product class for a product family, and creator is a tool for generating specific designs in minutes automatically from any product class. So these were the basic nomenclature. Let us see some shape and size related nomenclature. So shape variation is a geometry variation by suppressing or unsuppressing of parts and features. For example, in a crane, single or double girder is a shape variation. In a process tank, the bottom end, whether it is dish end or cone end, is a shape variation. Typically, any shape variable, when it is changed, many parts and features need to be suppressed and unsuppressed. Then comes the size variation. Size variation is a geometry variation done by changing dimensions. So, for example, in a crane, when you change the span or lift or load, that is size variation. Then comes shape variables. So, variables for shape variation are the shape variables. For example, girder type in a crane or tank bottom type in a process tank are shape variables. Then come the shape values. By the way, shape variables are also called classifications in CADEC sometimes. And then comes the shape values. They are also called options in CADEC. So shape values are predefined optional values of shape variables. For example, for a girder type shape variable, the single or double are the shape values. For tank bottom type shape variable of a process tank, dish end and cone end are the shape values. Then come the size variables. So size variables are all variables used in the design process. So they can be diameter, length, width, thickness, power, torque, number of holes, factor of safety, etc. So these size variables need not have any specific dimension to link to. They can be the variables used in the calculation process. So then we come to the last part, which is the process related nomenclature. So CADEC uses a word called formulator. So formulator is the process of design calculations. It involves defining shape and size variables and calculation logic. Then there is a variable table. So variable table is a table containing all size variables. It has four columns: serial number, variable name, value, and validation. Then comes the master model, which needs to be created in SolidWorks. So it's a generic assembly model for generalized product family for the product class. It has many alternate parts and features. It has more flexibility and less parent-child relationship. Then comes the model parameter. So model parameters are the parameters in the SolidWorks model. Any SolidWorks model is parametric, and by parametric we mean that by changing any parameter value, the model will get modified. These parameters are of two types. One is shape parameters and size parameters. Shape parameters are the suppress unsuppress, that is state at the rate base extrude 1 or state at the rate part 1 can be the shape parameters, and size parameters are uh, like, for example, d1 at sketch 1 or d1 at boss extrude 1. These are size parameters. Then comes the rule database. So rule database is uh, created for each product class. Uh, the variables, parameters, logic, etc. for that product class are captured in the rule database, and it is stored in the same product class folder. It's a file with an extension .cdc, and when you create any new product class, this rule database is created for every product class. Then comes crawler. So crawler is a process of capturing the assembly feature tree and I mean assembly tree and feature tree of the master model and all its components. Then comes linking. So linking is a process of linking model parameters with design variables. Then we have parametric equations. So parametric equations are created when we link the parameters with variables. So parametric equation is typically an equation having parameter on the left hand side and variable on the right hand side. And these are created for modifying the uh, uh, size parameters by the calculated design variables. Then there is a concept of mandatory and optional. So mandatory are all the parts and features which are always present in any design variation of a product family, and optional parts and features are optionally enabled based on customized needs. Then we have calculation rules. So we saw that all variables basic calculation logic is defined in variable table. The advanced calculation logic is defined in calculation rules. Then we have a concept of fixed, which is nothing but lookup. So when any variable doesn't have any formula, but it is uh, calculated based on lookup table, the variable value is defined as fixed in the variable table, and the lookup is defined in the calculation rules. Then we have a concept of data sheet. So data sheet is a output which is a list output or spreadsheet output or outputs like quotations or cost sheets or bill of materials. They are generated using data sheets. So this was about the background and nomenclature of CADEC. Thank you.